Hi everyone, we're back with another paper today. Today we're solving this mathematics paper. This is 9709 paper 1 2 February March 2024 series, and it's paper 1 pure mathematics 1. So you will be provided with the formula list MF19 and the time is 1 hour 15 minutes. So yes, what you guys need to know is that all answers, all non-exact answers should be given correct to 3 significant figures or 1 decimal place for angles in degrees only, unless a different level of accuracy is specified in the question. So this is the main concept. And another important point is that the maximum mark is 75. Okay, so before we dive into the paper itself, I'd like to talk about my Patreon. It's patreon.com/CAI papers solved. I'll add a link in the description. If you guys like my content, please remember to subscribe to the channel, like the video, share with your friends. It helps with the algorithm a lot, and it means a lot to me. And if you think you like my teaching techniques, you can opt for more help on Patreon if you support me here. The first tier is just for general support. The second tier is the most popular one, where you get access to solve papers for all math papers: pure 1, pure math 1, pure math 3, mechanics M1, as well as statistics S1, as well as for physics, chemistry and bio paper 1, 2, 4 and 5, as well as access to all my notes for AS and A2 physics and chemistry. And for the highest tier, you get access to all those perks, as well as a one-on-one video meeting with me every month via Google Meet, where we solve your personalized problems. Anyway, let's take a look at the threshold. So we are solving component 1, 2 today. The maximum available raw mark is 75. A is at 63, B at 57, C at 47, D at 38, and E at 29. Okay, so it's just like usual. It's nothing different. It's alright. So let's write it down. So out of 75, A is at 63, B is at 57, C is at 47, D is at 38, E is at 29. So if you look at the gap in marks, around 10 over here, 9 or 10. So A star, it shouldn't be 9 marks above. It might be 6 marks above this. So it might be at 68 or 69 out of 75. So yeah, for pure math 1, there's actually no room for error. You can just make 1 or 2 small mistakes, two small mistakes, I guess, and 1 large mistake at max, or else your A star is gone down the drain. So anyway, let's start the paper, shall we? Starting with question number 1, find the exact value of this. Alright, this is an integral. We have limits given, infinity 2 by x squared dx. We can write this as 2x to the power minus 2 dx. Let's integrate this. What do we end up with? 2x to the power minus 1 divided by minus 1, infinity 3. So that is actually minus 2 by x, infinity, and 3 over here. So if we solve this, it is minus 2 by infinity plus 2 by 3. Anything divided by infinity is 0. So yes, we end up with a final answer of plus 2 by 3, or so it seems. And since this is an exact answer, we will keep it as it is. Question number 2. The diagram shows part of the curve with equation y is equal to k sine half x, where k is a positive constant and x is measured in radians. The curve has a minimum point A. State the coordinates of A. Okay, so what you guys need to understand is, since there's a half x over here, the period will actually be 360 degrees, or since it's in radians, right? They said it's in radians. It's in radians, so the period will be 2 pi divided by half. So the total period is actually 4 pi. So what does that mean? What does this mean actually? Essentially, it will take 4 pi radians to complete one revolution. So if this is 4 pi, it takes 4 pi to complete one revolution. This will be at 2 pi and A will be at 3 pi. That's the x coordinate So that's 3 pi. And for the y coordinate, it's k sine half x. K is a positive constant. So that's the amplitude. This k is the amplitude. And since it's below the x-axis, it should be minus k. This should be plus k. So minus k. So we can write it in terms of k. They should have mentioned that. You write in terms of k, but that's what they want. Now a sequence of transformations is applied to the curve in the following order. So this particular order, a translation of 2 units in the negative y direction. So let's write it down. The initial curve was this, y is equal to k sine half x. So after the first translation, what will happen? If it's in the y direction, you just add or subtract with the function itself. So it's k sine half x minus 2. Okay, k sine half x minus 2. So translation of 2 units in the negative y direction. Next, a reflection in the x-axis. What does that mean? Check this curve. Suppose we have a curve like maybe this. This is the x-axis. So a reflection in the x-axis means that the new curve will actually go down over here. So all positive values turn into negative values. So what do we need to do? We need to input a minus sign in front of the function. So if I do that, minus k sine half x minus 2, we actually end up with 2 minus k sine half x. So that is our answer actually. Next, what do they want? Find the equation of the new curve. We found that out. And determine the coordinates of the point on the new curve corresponding to A. So this point, this will kind of change, okay? So the first thing that happens is the initial point, it was at 3 pi minus k. So 3 pi minus k. So the first change, the y coordinate will decrease by 2 because it moves in the negative y direction, vertically goes downwards. So it turns into 3 pi and minus k minus 2. And then next, what happens? Reflection in the x-axis. I just taught you guys. All positive values will become negative. All negative values will become positive. So essentially, actually, not all positive values, but basically the y values, that's what I meant. Because the x value, look, the x value does not change. It remains in the same position. For example, this 3 pi, right? If this gets reflected, look, it goes over here. This point goes over here. So the x coordinate does not change. It's just that the y coordinate changes its sign. So the x coordinate will remain the same at 3 pi and the y coordinate will just become positive at k plus 2. That is the answer. Does that make sense? Okay. Question number 3. A curve is such that dy by dx is 3 times 4x plus 5 to the power half. It is given that the points 1, 9 and 5a lie on the curve. Find the value of a. Fine. So how to do this? We have dy by dx is 3 times 4x plus 5 to the power half. So we can actually integrate this to find out y. Y is the integral of this. So let's do it. 3 4x plus 5 to the power 3 by 2 divided by 3 by 2 plus c. So after reciprocal, we actually get rid of these two 3's. 2 times 4x plus 5. Oh, I forgot something. My bad, guys. We will also end up with another 4 down here. Okay. So we can get rid of the 3's and we can get rid of this as well. I'll show you what I mean. Here, we can cancel this out. 4 and 2. So we actually end up with half 4x plus 5 to the power 3 by 2 plus c. So we know that the coordinates are 1, 9 and 5 respectively. Let's apply 1, 9. 1, 9. So 9 is equal to half 4 plus 5 to the power 3 by 2 plus c. 9 is equal to 9 to the power 3 by 2 into half plus c. So let's do that. 9 to the power 3 by 2 is 27 by 2. Okay. So 9 is equal to 27 by 2 plus c. 9 minus answer, that gives us a value of minus 9 by 2. So c is equal to minus 9 by 2. So what do we need to find? The value of a, 5 and a. Okay, fine, let's do this. So we now have y is equal to half 4x plus 5 to the power 3 by 2 minus 9 by 2. So we are going to input 5 in the place of x, right? So y is equal to half 4 times 5, which is 20. 20 plus 5 is 25 to the power 3 by 2 minus 9 by 2. So 25 to the power 3 by 2 is 125 by 2. That's 125 by 2. Y is equal to 125 by 2 minus 9 by 2. That gives us an answer of 58. So yes, the value of a should be 58. I'm just checking the answer. Yes, I am correct. Okay, let's move on to 4. Prove that sine theta plus cos theta whole square, sine theta plus cos theta whole square minus 1 by cos squared theta is the same as 2 tan theta. Okay, so for question 4, let's begin. So let's break this down. Sine squared theta plus 2 sine theta cos theta plus cos squared theta minus 1 divided by cos squared theta. So it can be written as sine squared theta plus cos squared theta minus 1 plus 2 sine theta cos theta by cos squared theta. So this can be sine squared theta plus cos squared theta is 1. You guys know that. So 1 minus 1 plus 2 sine theta cos theta divided by cos squared theta. So we can get rid of this, and we can also get rid of 1 cos theta. So we finally end up with 2 tan theta shown. So that is the way to do it. Hence solve this equation. So guys, on the left hand side we can just write 2 tan theta now. So 2 tan theta is equal to 5 tan cube theta, but do not cut tan, just bring it over to one side. So we can write this as 2 tan theta minus 5 tan cube theta is equal to 0, and then you can take tan theta common. So 2 minus 5 tan squared theta is equal to 0. So one of the equations is tan theta equals to 0. The other equation is 2 is equal to 5 tan squared theta, or tan squared theta is equal to 2 by 5, or tan theta is equal to plus root 2 by 5, and tan theta equals to minus root over 2 by 5. So let's solve this in the calculator. So the answer should be in degrees. It is from minus 90 to 90. Angle unit in degrees. So tan inverse 0, that gives us an answer of 0. And the rule for tan is it's the basic acute angle and 180 plus the basic acute angle. So 180 plus 0 is 180 degrees. So these are the answers. And on the other hand, root over 2 by 5, right? So tan inverse answer, that gives us alpha is equal to 32.3 degrees plus 180. That is 212.3 degrees. And over here, minus root over 2 by 5. Tan inverse answer is minus 32.3 degrees plus 180, that is 147.7 degrees. Notice how I put all the answers in one decimal place for angles in degrees. Okay, so what are our answers in this domain minus 90 to 90? We can write it down that theta is equal to 0 degrees, 32.3 degrees, and minus 32.3 degrees. These are our answers, these three. Fine. Okay, so number 5, a curve has equation y is equal to 3 by 2x square minus 5. Find the equation of the normal to the curve at this point. Okay, so to find this out, we first need to differentiate it. So y is equal to 3 divided by 2x square minus 5. So dy by dx is actually equal to, you can write it as this, 3 times 2x square minus 5 to the power minus 1. Okay, so it's actually minus 3 twice x square minus 5 to the power minus 2, and differentiation of 2x square is 4x. Okay, so this ends up as minus 12x 2x square minus 5 to the power minus 2. This is our dy by dx. Now we need to find out the equation of the normal at 2, 1. So here's the trick. Let's find out the gradient. Right, let's find out the gradient of the tangent first. Gradient of tangent is equal to minus 12 times 2. 2 cube is 8. 8 minus 5 to the power minus 2. So that is actually minus 24 divided by 3 square, minus 24 by 9, minus 24 by 9, which is minus 8 by 3, minus 8 by 3. So the gradient of the normal will be plus 3 by 8. Okay, there you go. So to find out the equation of the normal, what do we do now? It's the 2, 1. So y minus 1 is equal to plus 3 by 8 x minus 2. So 8y minus 8 is equal to 3x minus 6. So 8y is equal to 3x plus 2. 8y is equal to 3x plus 2. They wrote it like this. They wrote 3x minus 8y is equal to plus 2. 3x minus 8y plus 2 is equal to 0. It's the same thing, honestly. They want it in this form, basically. So yeah, that's our answer. Moving on to question number 6. How many do we have in total? I think we have like 11. Yeah, we have 11. We'll be done soon. We are at 6 right now. So it is given that the coefficient of x cube in the expansion of this is 432. Find the value of constant a. So 2 plus ax to the power 4, 5 minus ax. Let's break this down. So what will be the expansion? It's actually 2 to the power 4 plus 4c1 2 cube ax plus 4c2 2 square ax whole square plus 4c3 2 times ax whole cube plus 4c4 ax to the power 4 times 5 minus ax. So it's 16 plus 4c1 is 4 times 2 cube, which is 32. So that is 32 ax plus 4c2 times 2 square, which is 24. 24 a square x square plus 4c3 times 2, which is 8. 8 a cube x cube plus a to the power 4 x to the power 4 times 5 minus ax. So we are looking for the coefficient of x cube. How to find that out? The coefficient of x cube by multiplying two things. Either we can multiply this with this 5 over here, or we could multiply this with this over here. So we can write that down, that 24 a square x square times minus ax plus 8 a cube x cube times 5. So these two, right? So let's find out. This is the coefficient of x cube. So what do we end up with? It's minus 24 a cube x cube plus 8 5 is 40, 40 a cube x cube. So that is actually 16, right? So that is 16 a cube x cube. So this is the coefficient over here. We can actually write 16 a cube is equal to 432. So if we do the working, 432 by 16, and cubic root of that answer is actually a is equal to 3, and that is our answer. Okay, so a is 3. That's the only answer, positive 3. Number 7, the straight line y is equal to x plus 5 meets this curve at a single point. Find the value of constant k. So y is equal to x plus 5, and 2x square plus 3y square is equal to k. So we can substitute this inside. So 2x square plus 3 times x plus 5 whole square is equal to k, or 2x square plus 3 times x square plus 10x plus 25 is equal to k. So 2x square plus 3x square plus 30x plus 75 is equal to k. 5x square plus 30x plus 75 minus k is equal to 0. Fine. So now we are going to go for b square minus 4ac is equal to 0 because we know that they meet at a single point p. So b square, it's 30 over here. 30 square minus 4 times 5 times 75 minus k is equal to 0. So 30 square is 900. So 900 minus 20 times 75 minus k is equal to 0. 1500. So 900 minus 1500 plus 20k is equal to 0. So that's 1500 minus 900, 600. 20k is equal to 600. So the value of k is actually 30. So do they want the value of k only? Yes, the value of k is 30. This variant is actually pretty straightforward and simple. So find the coordinates p. Okay, so now we know that we can input the k over here. So let's do just that. So 5x square plus 30x plus 45 is equal to 0. So we can actually simplify this. X square plus 6x plus 45 by 5 is 9. I don't know why I did that using the calculator. That was a rookie mistake. Okay, so let's do this. Okay, you can use the calculator if you want. 169. So we get minus 3 only. How? 3x plus 9 equals to 0. So x plus 3 x plus 3 is equal to 0. So x plus 3 plus x plus 3 is equal to 0, or x plus 3 square is equal to 0. So the only value that we get is x is equal to minus 3. So now to find a y is equal to x plus 5, y is equal to x plus 5. So y is equal to minus 3 plus 5, which is 2. So the coordinates of p are minus 3 and 2. Okay, let's check with the mark scheme. Yes, I'm correct. Let's move on to question number 8 then. An arithmetic progression is such that its first term is 6 and its 10th term is 19.5. So a is 6. The first term is 6. And tn plus 1, right? tn plus 1 is equal to a plus n minus 1d. So we are looking for the 10th term, which is a plus 10 minus 1, which is 9d, 10 minus 1. Okay, so this t10 is actually equal to 19.5. So what can we write? A plus 9d is 19.5, or 6 plus 9d is 19.5. 9d is equal to 13.5. So it's 13.5 by 9. 13.5 by 9 is 1.5. The common difference is 1.5. So we need the sum of the first 100 terms. So what's the formula for the first 100 terms? It's n by 2. And then what do we have? 2a plus n minus 1 d. So it's 100 by 2. 2 times a, that is 12, plus n minus 1, 99d. d is 1.5. So what do we end up with? 50. 12 plus 99 into 1.5, which is 148.5. Okay, so we get 8025. 8025 is our answer. 8025. Yes, I checked. It is the correct answer. Let's move on to number B then. A geometric progression is such that a1 is 24 and the common ratio is half. The sum to infinity of this geometric progression is denoted by s. The sum to infinity of the even numbered terms is denoted by se. Find the values of s and se. Okay, so the first geometric progression is such that a1 is 24 and the common ratio is half. So the sum to infinity of the geometric progression is denoted by S. So the sum to infinity of the formula is A divided by 1 minus R. So if we just input that over here, what will that be? 24 divided by 1 minus half. Okay, so that is basically S is equal to 24 by half itself. So S is actually equal to 48. That's very good. Now moving on to the next one, we are now talking about this even numbered progression. So look, we know that a2 by a1 is equal to half. Sorry, the 2 should be down below. A2 by a1 is equal to half. So we can find out a2. A2 by a1, which is 24, is equal to half. So a2 is actually 12. So the terms, they're like this: 24, 12, 6, 3, 1.5, and so on, or 3 by 2 and so on. So this is a1, a2, a3, a4, a5, and so on. So now we are going to find out SE. So this is a new progression. It goes from a2 to a4 and then to a6, which happens to be 1.5 by 2, which is 0.75, I guess. 0.75, yeah. So what is the common ratio for this second geometric progression? So the new common ratio will actually be, it's actually a4 by a2, right? So for example, it's going to be 3 by 12, which is 1 by 4. And the sum to infinity for this progression will be a2 divided by 1 minus the new common ratio, 1 by 4. So SE is actually equal to a2, which is the first term, is 12 for this progression. 12 divided by 3 by 4. So 12 divided by 3 by 4 is actually 16. And that is the answer. So see if you guys understood. I tried to break it down as much as possible. Essentially, the formula for sum to infinity is first term of the progression divided by 1 minus common ratio. So for this one, we knew everything, so it was easy. But for the one with the even number terms, like a2, 4, 6, the second, fourth, sixth, eighth term, the first term was 12. We had to find that out. And we had to find out the common ratio as well, using the fourth term and the second term of the main geometric progression. Yeah. So that's the general idea. Next, 9. The functions f and g are defined for all real values of x by these. Given that the range of the function gf is greater than or equal to 39, find the value of k. So let's find out g of x first. So we are going to input f into g. So gx is this 5x minus 1. So instead it will be 5, 3x minus 2 whole square plus k minus 1. So that's 5, 3x minus 2 whole square plus 5k minus 5. Basically this. Or I don't think we need to break it down. Why? Because gfx is greater than or equal to 39. That's what this stated. So 5 times 3x minus 2 whole square plus k minus 1 is greater than or equal to 39. then 5 times 3x minus 2 whole square plus k is greater than or equal to 40, we get 8 then, right? 3x minus 2 whole square plus k is greater than or equal to 8. Okay. So we are here now. Was it better if we broke it down actually? Because now I'm actually in a complicated scenario. I think it's better if we broke it down. Like the thing I was doing initially was right. Let's see. So 5, 3x minus 2 whole square plus 5k minus 1. We got this. Now we basically said that g of x was greater than or equal to 39. So we can write this exact thing over here. Wait. Here you go. It's greater than or equal to 39. Okay, so what we need to realize is the range of this function g of x, okay, is greater than this. So look, if this was a function, like if we wrote it like this, something like, you know, maybe y is 5. This is basically a quadratic equation, right? It's in the completing squares form. Completing squares. So for the value of, you know, x is equal to 2 by 3, since it's a positive value, this is the minimum value over here, this plus k. Essentially, this is the minimum value, right? So here we have the same thing. Take a look at this expression. So for the value of x is equal to 2 by 3, the minimum value will be 5k minus 1. That's the general idea. Okay, so we can write that down, that the minimum value, because it's a minimum curve, because it's positive over here, is actually 5k minus 1. But we know that the minimum value, or the least value, or the minimum value would be 39. So this 5k minus 1 is actually equal to 39, because this is the minimum value of the graph. It's like this. The graph is like this, and the minimum value is 39. And that 39 also corresponds to this value over here, 5k minus 1. So we can equate those. So 5k is equal to 40 and k is equal to 8. That's the answer. Hope you guys understood. I just had a problem figuring out that this was in the completing squares form, completing squared. Okay. Now for this value of k, determine the range of the function fg. So now we are going to go for fg. We are going to input g into fg. So fgx is equal to 5x minus 1, right? X minus 1 minus 2 whole square plus k. K will be 8 instead. So fgx will be 15x minus 3 minus 2 whole square plus 8. There you go. So we have to find out the range for this. So honestly, we could rearrange it a bit. Like I can take 5 common over here, so we actually end up with 3x it doesn't really matter because the minimum value is 8 for all real values, but we should take 15 out. Okay, it should be like this. 15 should be taken out, and this turns into 5 by 15, which is 1 by 3. So it can be written like this: f gx is equal to 15 square 225. There you go. 225 x minus 1 by 3 whole square. That's that. This is basically the idea, plus 8. So for x is equal to 1 by 3, the minimum value is 8. So since it's a minimum curve, it's a positive value over here. We can write down that the range of f g x, is actually greater than or equal to 8. This is our minimum value. So do you see all this I did over here to come to this? This wasn't necessary. You could just figure it out using the form over here. Anyway, the function h is defined for all real values of x and is such that ghx is equal to this. Find an expression for g inverse. So ghx is equal to 35x plus 19. So let's find out g inverse x. What is gx? It's 5x minus 1. Gx is 5x minus 1. So let's find out g inverse x first. How? So let gx be y. So y is equal to 5x minus 1. So 5x equals to 1 plus y. X is equal to 1 plus y by 5. There you go. So g inverse x is equal to 1 plus x by 5. That's the general idea. Or we could write it as 1 by 5, 1 plus x. There you go. Now, how to do this actually? So something was put, like h was put into g. Okay, h was put into g. So you could think of it like this. G hx is equal to this 5 hx 5 hx minus 1. There you go. And this resulted in 35x plus 19. So you could even solve it this way, like you could do this 5 hx minus 1 or is equal to 35x plus 20, and if you divide by 5, hx is actually 7x plus 4. I actually find this easier. This is much easier to do. This is option 1. Okay, and for option 2, what is the general idea? We have g inverse x over here. We have g inverse x. Okay, so if we have the inverse of this function over here, the general idea is you have to input this over here. Okay, so hx will actually be 1 by 5, 1 plus ghx, like this. So hx is equal to 1 by 5, 1 plus 35x plus 19. So hx is equal to 1 by 5, 35x plus 40. So hx is equal to 7x plus 8. Sorry, 7x plus 4. Wait, I wrote 20 here, right? It should be, sorry, 40 here. 19 plus 1 is 20, 7x plus 4. Okay, so this is the general idea. To find out hx like this, the rule is hx will be equal to this g inverse g h x. This is the general idea. You have to put this GH inside G inverse X, and then the G inverse and G will cancel out and you will get HX. That's the general idea. Okay, so you have to put this GHX into G inverse X, then you will get HX. That's how it works. So that's what they wanted you to show, but the other way was also acceptable. Okay, no problems there. Next, find the equation of the tangent to the circle at point -6,9, given that it has center -4,5 and radius root over 20 units. It intersects the y-axis at points A and B. The size of angle ACB is theta radians. Okay, let's do this. This is a root 20. This is also root 20, and this point is -4,5. So where is -6,9? -6,9. Maybe somewhere over here. So we have to find a tangent at this point. Okay. So how to do it? We have to find out the gradient of this one and then the gradient of this. Okay. So gradient of this radius is actually equal to 9 minus 5 divided by -6 plus 4, which is 4 by -2, which is -2, and then the gradient of tangent, which is a normal here, ironic, is half. So then what do we do? Y minus 9 is equal to half x plus 6. 2y minus 18 is equal to x plus 6. 2y is equal to x plus 24. That's that. 2y is equal to x plus 24. Or y is equal to half x plus 12. That also works. How? They wrote it this way. They wrote y minus 9 is equal to half x plus 3. So y is equal to half x plus 12. Same thing. Find the equation of the circle in this form. Okay. Doable. So I honestly prefer it this way, in this form. X, the centers will be inverted. X plus 4 whole square plus y minus 5 whole square is equal to radius whole square, root 20 whole square, which is x plus 4 whole square plus y minus 5 whole square equals to 20. Then let's break this down. X square plus 8x plus 16 plus y square minus 10y plus 25 is equal to 20. So x square plus y square plus 8x minus 10y, and let's do the math. 16 plus 25 minus 20, it's 21, plus 21 is equal to 0. So shown answer. Find the value of theta, correct to 4 SF. We have to find this angle. So it lies on these 2 points A and B. They actually lie on the y-axis. So we know that on the y-axis the x coordinate is 0. So if you actually input an x coordinate of 0 over here, we actually get something like this. Y square minus 10y plus 21 is equal to 0. So if you solve this equation, we get y is equal to 7 and 3. Okay, so we have the coordinates now. A is 0, 7, B is 0, 3. We also know this coordinate over here. Okay. So the length of this line AB, the length of line AB will be 4, and we also know the length of AC and BC. So according to this, we can use the cosine rule, right? What is the cosine rule? 4 square, the length opposite to the angle, 4 square is equal to the two lengths square, AC square and CB square, is equal to root 20 square plus root 20 square minus 2AB root 20 cos theta. So 16 is equal to 20 plus 20 minus 2 into 20, which is 40 cos theta. So 16 minus 20 minus 20 minus 24 minus 24 is equal to minus 40 cos theta. So if you do the working, it's 24 by 40, and make sure your calculator is in radians. So cos inverse of 24 by 40, that gives you an answer of theta is equal to 0.9273 to 4 SF. Okay, 0.9273. That's how you do it. Cosine rule. Find the perimeter and the area of the shaded region. So this shaded region over here. Perimeter is pretty simple. We know that this length is 4. We just need to find out the arc length. So let's find out the arc length. S is equal to arc theta, which is root 20 times 0.9273. So answer times root 20, that gives us an answer of 4.147. So perimeter will actually be 4 plus 4.147. So since they didn't mention anything, it's going to be given to 3SF 8.15. Yeah, 8.15. That's that. And then we move on to the area. So for the area, what will it be actually? It's going to be the area of the sector minus the triangle. So area of the sector is half r squared theta, and the area of the triangle is half AB sine theta. Okay, so let's go for it. Half r squared theta, so root 20 whole square, which is 20, times theta is 0.9273, minus half into AB root 20 whole square, which is again 20, times sine 0.9273. So let's do this. 10 times 0.9273 minus 10 times sine 0.9273. So I'm getting an answer of 1.27 to 3 significant figures, and that is my final answer. Okay, there you go. Moving on to the final question, which is question number 11. The diagram shows the curve with equation this. The curve crosses the x-axis at points A and B and has minimum point M. Find the exact coordinates of M. Okay, let's do this. Y is equal to 2x to the power minus 2 by 3 minus 3x to the power minus 1 by 3 plus 1. So dy by dx, what will it be? 2 times minus 2 by 3 times x into minus 2 by 3 minus 1 is minus 5 by 3, minus 3 times minus 1 by 3 times x, minus 4 by 3 I think, minus 1 by 3 minus 1 is minus 4 by 3 plus 1. Okay, so this actually is minus 4 by 3 x to the power minus 5 by 3 and plus x to the power minus 4 by 3 plus 1 is equal to 0. Because we are going to find out the maximum point, we need to equate dy by dx with 0 actually. Okay, so how do we progress? Oh, I actually made a mistake. The differentiation of 1 is 0, right? So we will just ignore that. Sorry. So what to do here? What to do here basically? The general idea is you have to take a few things common here. What does that mean? Let's take basically it's 5 by 3 and 4 by 3 over here. So what does that mean? There's an extra 1 by 3. Okay, there's an extra 1 by 3 over here. If you take x to the power minus 4 by 3 common, what do we get? Minus 4 by 3 x to the power minus 1 by 3 plus 1 is equal to 0. This is what we get. Now x to the power minus 4 by 3 is equal to 0. This is one way. And over here 4 by 3 x to the power minus 1 by 3 is equal to 1, or x to the power minus 1 by 3 is equal to 3 by 4. So if you want to solve this, what do we get? 1 divided by x to the power 1 by 3 is equal to 3 by 4. So if you cross multiply, x to the power 1 by 3 is actually equal to 4 by 3 there and back again. So if you cubic root this, 4 by 3 cube, that is 64 by 27. 64 by 27. And over here, this is actually not applicable. As you know, we are looking for m. The value can't really be 0. So this is not applicable. So we have our answer, which is x is equal to 64 by 27. But they want the coordinates. So what do we need to do now? We know that y is equal to this, right? We know that y is equal to this. So what we can do is y is equal to 2 times 64 by 27 to the power minus 2 by 3 minus 3 times 64 by 27 to the power minus 1 by 3 plus 1. Okay, so 64 by 27 to the power minus 2 by 3 is 9 by 16. That is 9 by 8. 64 by 27 to the power minus 1 by 3. That is 3 by 4. No, I didn't multiply it, sorry, into 3. 9 by 4. So 9 by 8 minus 9 by 4 plus 1. 9 by 8 minus 9 by 4 plus 1. Minus 1 by 8. Y is equal to minus 1 by 8. There you go. So the coordinates are 64 by 27 and minus 1 by 8. Those are the coordinates for m, the minimum point. Now find the area of the region bounded by the curve and the line segment AB. The curve and the line segment AB. So we need the x coordinates of these points, right? So let's do that. We need to equate it with 0 basically. It's worth 7 marks though. So y is equal to 0. Let's do this. 2x to the power minus 2 by 3 minus 3x to the power minus 1 by 3 plus 1 is equal to 0. Or 2x to the power minus 2 by 3 minus 3x to the power minus 1 by 3 is equal to minus 1. Now, honestly speaking, I think this is the better way to do it. You could do this. Let x to the power minus 1 by 3 be a. Okay. So 2a square minus 3a plus 1 is equal to 0. If you solve this quadratic equation, 2 minus 3, 1. You get a is equal to 1 and a is equal to half. Okay. So we can actually write x to the power minus 1 by 3 is equal to 1 and x to the power minus 1 by 3 is equal to half. So x to the power 1 by 3 is equal to 1, and over here x to the power 1 by 3 is equal to 2, just reciprocal. Now cubic root, this turns into 1, this turns into 8. So we have 1 and 8. Okay, so this is the first part of the journey. Why could I do this? Because x to the power minus 2 by 3 is the square of x to the power minus 1 by 3. Now we need to integrate, yeah? Because we have the limits now. So just take this whole thing and just integrate. Okay, so integral of 2x to the power minus 2 by 3 minus 3x to the power 1 by 3 plus 1, and the limits are 8 and 1. So let's do this. Minus 2 by 3 plus 1, which is 1 by 3. 2x to the power 1 by 3 divided by 1 by 3 minus 3x to the power 2 by 3 divided by 2 by 3 plus x, and no plus c, sorry. It's just 8, 1 over here. So that's 6x to the power 1 by 3 minus 9 by 2 x to the power 2 by 3 plus x, 8, 1. So let's input that in. 6 cubic root of 8 minus 9 by 2, 8 to the power 2 by 3 plus 8 minus 6 plus 9 by 2 minus 1. So we end up with 12 minus 8 to the power 2 by 3 times 9 by 2 is 18, minus 18 plus 8 minus 6 plus 9 by 2 minus 1. So 12 minus 18 plus 8 minus 6 plus 4.5 minus 1. That gives us an answer of minus half. But since the area can't be negative, we are just going to take a positive value of 0.5. So the area is actually 0.5 or half. That is our answer. Okay guys, that was it. Not a really tough paper. There were a few tricky parts though. Hopefully I could clarify them and explain in a very concise manner. Quick shout out to my top tier patron for the month, Tim. If you want to be featured on the end screen, please do consider supporting me on Patreon if you like the content, where you get access to one-on-one meetings with me on the highest tier, as well as all my solved papers and notes. So I'll attach the link for the May-June 2023 paper 1-2 up here, and the paper for the February-March 2023 paper 1-2 down here, and the playlist for P1 Pure Math 1 up there. And remember to hit the subscribe button. See ya guys, bye bye.